Okay, so the Christmas revision, we're going to first start off by looking at how to simplify algebraic expressions, and we'll learn how to remove brackets and basically gather and put like terms together. Okay, so here's an example. Simplify 2x minus 5 multiplied by 4x plus 3 times 5x minus 4. Note that there's no equal signs in this algebraic expression. We're not using the word solve, so we're not looking to find an actual value for the variable that is x. We're just simplifying the expression, so don't be tempted to start adding equal signs inside here and everywhere that people tend to do. Okay, so here's the solution. We multiply 2x by 4x, we get 8x squared. 2x by 3 is plus 6x. Minus 5 by 4x is minus 20x. Minus 5 by 3 is minus 15. Remember, you have your minus by plus gives a negative. And then we have 3 by 5x is plus 15x, and 3 by minus 4 is minus 12. We gather our like terms, starting with our variable of the highest power, the squared, on the left. So we have 8x squared plus 6x minus 20x, and we bring this 15x here, plus 15x. Minus 15 takes that into account, and minus 12. So that gives us 8x squared plus 1x minus 27. Now, how to evaluate the value of an algebraic expression when the variables are have assigned values. So, for example, now in this case we will end up with a value, a constant or a number for the expression. Okay, we're giving given if x equals 3 and y equals minus 2, find the value of this expression, x squared minus 3 by x by y plus 2 times y squared. And we just have to make sure that we remember that we use BIMDAS here, where we'll work with anything that's going on inside brackets first, followed by anything that has a power or is squared or cubed, the indices. Then we'll look at the multiplications, any divisions, any additions, and any subtractions. So here's our expression, and here's our expression rewritten. Where we see x, we put in a 3 here, and where we see y, we put in minus 2. And we leave them in the brackets. So we then first work out what's going on inside this bracket. This is a 3, and it's squared, so that's 9. And also on this side here, because of this squared here, we say minus 2 by minus 2 is 4. So we have 9 minus 3 times 3 by minus 2, that's the x value and the y value, all safely kept in their brackets, plus 2 times 4. The next line then is 9 minus, we'll have minus 3 by 3 is minus 9, so we have 9 minus 9 times this minus 2 still, plus the 2 times 4. Next line then, we'll work out what minus 9 by minus 2 is, because that's multiplication. We have 9 plus 18 plus 2 times 4. And now we'll finish off by working out this multiplication before we attempt to add these. So we still have 9 plus 18 plus 2 by 4 is 8. And finally we'll add all those up, coming towards the end of our BIMDAS, and that gives us 35. Now we're asked how to solve linear equations. Okay, so now the word solve is used, so we will be finding an actual numerical value for the variable x. But here is the equation. It's like an algebraic expression, but because it's an equation, it has the equal sign. Okay, so we're asked to solve 5 times 3x minus 2 is equal to 3 times 2x minus 1 plus 2x plus 1. Okay, so 5 by 3x is 15x, 5 by minus 2 is minus 10, 3 by 2x is 6x, 3 by minus 1 is minus 3, plus 2x plus 1. So we have 15x minus 10 is equal to 6x, bring over your 2x so it's beside the 6x, gather your terms, plus 2x minus 3 plus 1. So 15x minus 10 equals 8x minus 2. The 8x crosses the bridge and becomes minus 8x, and the minus 10 hops over here and becomes plus 10. So we have 15x minus 8x is 7x, minus 2 plus 10 is 8. Therefore, divide both sides by the coefficient of x. Divide both sides by 7, and we get x is equal to 8 over 7. Or x is equal to 1 1/7. Now, let's look at solving problems using linear equations like the one above, but we have to generate the linear equation first. So here's an example. Anne is 3 years older than Helen. If twice the sum of their ages is 50 years, how old is Anne? Well, let's say that Helen is X years old and Anne is 3 years older. So Anne is X plus 3, that's her age. Now, twice their sum. Well, the sum of Helen and Anne must be Helen's age X plus Anne's age X plus 3. The sum of those, but if twice the sum of their ages, so we have to put all that in brackets and multiply that by 2 and let that equal 50. If twice the sum of their ages, 2 times the sum of their ages is 50. How old is Anne? So we'll clean this inside the brackets here in the next line. So x plus x is 2x plus 3, all equals 50. And then we'll say 2 times 2x is 4x, 2 times 3 is 6. So 4x plus 6 is 50. So 4x must be equal to 50 minus the 6 here. So 4x is equal to 44. X must be equal to 44 divided by 4. X is equal to 11. So Helen would be 11 because that's x. Anne is 11 plus 3. Anne is 14 years old. Okay, let's look at how to solve inequalities. So here's an example. Solve minus 5 less than or equal to 1 minus 3x less than or equal to 10. And our answer x, or our values for x, will be real numbers. Okay, and if you remember back when we're doing inequalities and the number line, if the solution is an element of the set of real numbers, which is what this means here, then when we draw our number line, we'll use a really thick line, and we also have to consider these symbols here are less than or equal to symbols. They signify the use of full dots. A less than or greater than would be open dots when we write our number line. Okay, so let's have a go at solving this. So the whole problem is minus 5 less than or equal to 1 minus 3x less than or equal to 10, but we just take this half first, okay, and we have minus 5 is less than or equal to 1 minus 3x. Now, I always like to have my variables on the left, so I'll bring this over here and it becomes plus 3x less than or equal to 1, and I'll bring this over here, it becomes plus 5. Okay, so I have 3x is less than or equal to 6, x must be less than or equal to 6 over 3, x is less than or equal to 2. That's half the problem done. I'll then take this piece of the puzzle here, as I've noted here, and I'll say 1 minus 3x is less than or equal to 10. So minus 3x is less than or equal to 10 minus this one. Minus 3x is less than or equal to 9. I don't want to find out a minus x value, I want a positive x value, so I'll multiply both sides by minus 1, but in doing so I must switch the direction of this sign the other way. Okay, so notice how this has switched compared to there. So I have 3x is now greater than or equal to minus 9. X is greater than or equal to minus 9 over 3. X is greater or equal to minus 3. So bringing that together, this bit says that x is less than or equal to 2, and this bit tells us that x is greater than or equal to minus 3, and if you look here, that's what that says, x is greater than or equal to minus 3. So to draw that on the number line, x is less than or equal to 2, it's greater than or equal to and including the minus 3, so we get a full dot and we draw a really thick line. Now let's look at how to factorize expressions using the highest common factor. Okay, so solve, or factorize, I should say really, factorize 5x y squared minus 20x squared y. Well, the first thing we do is we look at the numbers 5 and 20, and we pull out the highest common factor of 5 and 20, and that's 5. Then we look at the variables, and we have x here and x squared there, and the highest common factor of variable to those two terms is x, because x will go into both of those. It's not x squared, because x squared doesn't go into x, okay? And we look at our y squared and our y, and we note that y is the highest common factor of those two terms, okay? So we write 5xy outside our brackets, and then we divide 5xy into 5xy squared, and we'll get y, and 5xy into minus 20xy squared is minus 4x. If you recall, the longer version of doing that, it would be 5xy into 5xy squared over 5xy minus 20xy squared over 5xy. Okay, and that would mean that this cancels, this cancels, and that goes once. So we end up with our y, and we have 5 goes into that 4 times. The x right there, sorry, x will cancel with that, and the y's will cancel, so we'll just have x there. So if you remember, the longer way of doing that is to write the highest common factor outside, write down every term inside, and divide every term by the highest common factor that you have outside. Okay, let's look at how to factorize by grouping. So we have an expression 6x squared plus 2a minus 3ax minus 4x. Well, the idea is that you generally start by grouping the first two expressions and the second two, and you look for some highest common factors associated with those, and there isn't any if I try to group them like that. So then I'll take the first and the third, and I'll group them together, and the second and the fourth. And again, there isn't any highest common factor that I can see quickly there that will work. So finally, I'll try and I'll take the first and the fourth, and I'll group them like that, and the second and the third together like that. And I'll see, and I can see that 2x will go into 6x squared, and it'll also go into 4x. 2x will go in 3x minus 2 times, and a is the highest common factor to both these two terms, and 2a divided by a is 2, and minus 3x divided by a is minus 3x. So now I have 2x by 3x minus 2 plus a by minus 3x plus 2. So I want to rewrite this term. So kind of, so it looks like, so actually I've done it already, sorry. I had here 2 minus 3x, and I've just rewritten this here, keeping the minus 3x and the plus 2, but the other way around, so that I have x here and 2 there, like I have an x here and a 2 there. And it helps me see that this term is similar to this term in every way except for the signs. So I can fix that by multiplying this, and this, sorry, this term, and this term by minus 1, so that I'll have 2x times 3x minus 2 minus a times 3x, which looks like this, minus 2, which looks like that. So by multiplying each of these terms here by minus 1, I now have generated a factor here similar to the factor there. So and it's my standout factor, my 3x minus 2, and my other factor is 2x minus a, 2x minus a. How to factorize using the difference of two squares. The trick to factorizing using the difference of two squares is to make sure that your constant is a perfect square, like 25, and the square root of 25 is 5, 5 fives are 25, and this constant here, the square root of that is 9, so AC1 is a perfect square as well, and a squared and b squared are also perfect squares. So if all these conditions are true, remember these variables here can just be a 1, because square root of 1 is 1, 1 is a perfect square as well. Then you can go ahead and just write out your two brackets, your plus and your minus, and the square root of 25 is 5, you write 5 there and 5 there, square root of a squared is a, so you write a and a, square root of AC1 is 9 and 9, and square root of b is b and b, and that's the solution to that problem there. Or if we might have a problem like this where we have 12x squared minus 75y squared, and whilst these are perfect squares, these variables, square root of x squared is x, the square root of 12, is not is not a whole number, sorry, or 75 either. But so in other words, we can't just crack on and do this brackets and positive and negative and so on. The x and y's will work, but the coefficients won't. So what we can do is look for the highest common factor of 12 and 75, and that's 3, and take that outside and divide 12x squared by 3, we get 4x squared, and 75y squared divided by 3 is minus 25y squared, and you'll see then that this is a perfect square, 2 and 2, This is a perfect square. 5 and 5 are the roots of that, square roots of that, and x squared and y squared, x and y, x and y. Okay. Let's look at factorising quadratic expressions using the guide number technique. So factorise 3x squared plus 10x plus 8. So we write out our expression and we say 3 by 8 is 24, and we divide 1 into 24 and we find those two factors, 1 and 24. 2 into 24, those two factors, 2 and 12. All the while we're looking to see if we can somehow make 10 out of our factors by adding them. 3 and 8, no. 4 goes into 4 6 times, so 4 and 6 will work. So we'll rewrite this expression now. So it now looks like 3x squared plus 4x plus 6x plus 8. Now, why do we know that we've two pluses here? Well, we know we've got two pluses here because this sign is positive. It tells us that both the signs of our factors will be the same. But what is that same? That's the same. They'll both be positive. Okay, so this is the indicator and this is what that same is. If this value here was a negative, then the signs would just be different, full stop. And you'd aim to make whatever's in here out of a positive and a negative, or a negative and a positive for those two. Anyway, so with 3x squared plus 6x plus 4x plus 8, I've rearranged those because I can kind of see that 3 will go into 6 and 4 will go into 8. Because I'm going to factorise by grouping now. I'll take 3x out of these first two expressions, and I'll have 3x into 3x squared goes x, and 3x into 6x goes 2. And I'll take 4 out of this pair here, and I'll have 4 into 4x goes x times, and 4 into 8 goes twice. So my standout factor here is x plus 2, because it appears twice, and my other factor is 3x plus 4. Let's look at another one. Factorise 2x squared minus 11x plus 12. So 2 by 12 is 24. It just happens to be the case with these two examples, not on purpose. So I'm looking to make 11, okay, and I'm looking to make 11 out using the same signs because this is positive, but what are those signs? They're both minus. So I can see that 3 and 8 will add to 11, or minus 3 minus 8 will give me minus 11. So I go with minus 3 and minus 11. So I write out this as 2x squared, sorry, that should be minus 3 minus 8x plus 12. So that gives me, and I'll bring this minus 8x over here, so that should be 2x squared minus 8x minus 3x plus 12. Okay, so then I will, so sorry, I have 2x squared minus 8x minus 3x plus 12. So I can try and factorise these two by taking out the 2x, and 2x goes into 2x squared x times, and 2x into minus 8x goes minus 4. Okay, and then I'll take out my minus 3 here, and that will go into minus 3 into minus 3x will go positive x times, and minus 3 into minus 12 will be minus 4. So my standout factor is x minus 4, and my other factor is 2x minus 3. So sorry, that should be 2x minus 3. Okay, so I made a mistake there with the signs, but you can see it's just been rectified here. So sometimes we're asked to use factors to simplify quadratic expressions. So we have a quadratic expression here, and we have another algebraic expression there, one over the other. So to simplify this whole expression here, we'll first find the factors of 2x squared plus 11x plus 15. Again, using the guide number technique, 2 by 15 is 30. We'll find what factors of 30 will give us 11x if we add them together, because it's a positive sign, which means signs will be the same, they'll both be positive. So I'll end up with 2x squared plus 5x plus 6x plus 15. And I'll factorise these two, and I'll pull x out, and I'll have x into 2x plus 5. I'll take 3 out of these two, and I'll end up with 3 into 2x plus 5. So my standout factor is 2x plus 5. My other factor is x plus 3. And what I'll do is I'll simply write all of that over, I'll say, sorry, 2x squared plus 11x plus 15 over 2x plus 5 is the same as these factors, because that's the same, all over 2x plus 5. And these guys will actually cancel, and I'll just be left with x plus 3. Let's add algebraic fractions. So we're asked to express as a single fraction. So there's no equal sign anywhere here, and we're going to use our containers technique. So what we'll do is we'll find the lowest common multiple of the 2 and the 3, and that's 6. We'll draw a line and put our lowest common multiple underneath, and then we'll open up 4 containers, 2 for this term, minus sign, and then 2 containers for this term here. Okay, and we'll write what's in the top in here and what's in the top here there, and then we'll say 2 into 6 goes 3 times, and 3 into 6 goes 2 times, and then we'll multiply all this out. So we'll have 5x minus 3 times 3, that's 5x minus 3 is 15x, and 3 by minus 3 is minus 9, minus sign, leave that there and do some big brackets here. 2 by 2x is 4x, and 2 by 1 is 2. So I've minus brackets and some terms inside, so I'll clean that up now, and I'll say that's the set, well over 6, sorry. I'll say that's 15x minus 9, minus, open the bracket, 4x becomes minus 4x, and minus plus 2 is minus 2. So I have 15x minus 4x is 11x, and minus 9 minus 2 is minus 11, all over 6. Now I'm going to solve some equations here with fractions. Okay, so this has an equal sign. The solve word is there. So I'm actually going to find a value for x. So I don't use containers for these. I look for the lowest common multiple of 5, 4, and 1. There's no balancing gun on here. Sometimes I have to put a 1 under a term if there's no number there. But the lowest common multiple 5, 4, and 4 is 20. So I'm going to multiply all 3 terms by 20. And I like to put the 20 over 1 times the 2x minus 3 over 5 plus 20 over 1 by 1 over 4 equals 20 over 1 by x minus 1 over 4. Then I'll look to cancel, so I'll see 5 goes in once, goes in there 4 times, that gives me 4 by 2x minus 3. 4 goes in there once, goes in there 5 times 1. And 4 goes in 1, goes in there 5 times x minus 1. Multiply that out, 4 by 2x is 8x minus 12 plus 5 equals 5x minus 5. So bring over your x's, so this 5x comes over here, becomes minus 5x. 8x minus 5x equals my minus 5 from here, plus the 12 minus 5. So 8x minus 5x is 3x, minus 5 plus 12 minus 5 is 2, x is equal to 2 over 3. And if you were to plug that back into here, that would all equate. Let's look at solving problems with fractions. So x and x plus 1 are 2 consecutive numbers. When 1/5 of the smaller number, that's x, is added to 1/4 of the larger number, that's the x plus 1, and 1/4 of that is that over 4, the result is 7. So here's my equation. So I'm going to solve this equation now that I've taken the story and I've generated the equation. But I can see here straight away there's nothing underneath the 7, so I'll balance it by putting a 1. Then I'll look for the lowest common multiple of 5, 4, and 1, and that's 20, and I'll multiply all terms by 20, which helps me kind of flatten the equation with the fractions to an equation with no fractions. Okay, so I end up 5 goes in there once, 4 gives me 4x, 4 goes in there once, 5 gives me 5 by x plus 1, and 7 by 20 is 140. So 4x plus 5x plus 5 equals 140. So 4x and 5x is 9x. 140 minus this 5 becomes 135. So x is 135 over 9. X is equal to 15. Okay, so let's look at algebraic division. Let's divide x cubed plus 5x squared plus 11x plus 10 by x plus 2. So we write our equation in here and what we're dividing into that outside, and we say x goes into x cubed, x squared times, x squared by x is x cubed, x squared by 2 is plus 2x. We draw the line, we change the sign of both, so these two will cancel, and 5x squared minus 2x squared is 3x squared, and we'll bring down our 11x and our 10. X goes into 3x squared plus 3x times, plus 3x by x squared gives us 3x squared, and plus 3x by 2 gives us 6 plus 6x, and So we've multiplied these two out, so we'll draw the line, change the sign, and we get they'll cancel. 11x minus 6x is 5x, bring down by 10, 5x plus 10 there. X goes into 5x plus 5 times x is 5x, and 5 times 2 is 10. Draw the line, change the sign of both, and they'll both cancel, and the sum is complete. Now let's look at rearranging formulas. So make x the subject of the formula that is y equals c minus ax. Well, the solution to these using our the method that we've learned in class is we write out the equation and we ask ourselves what is happening to x starting at x. And the first thing we notice is that x is being multiplied by a and c is being added to it. Okay, so our solution will lead us to taking, if we've add c here, then we subtract c from both sides. Remember, if it's an addition or subtraction, we do it to both sides of the equation. And the next thing we'll do after that is, if we've a multiply a here, we'll divide all terms by a. So the first step is to rewrite this, taking into account this first move. So we write y minus c on this side equals c minus ax, what we have already, minus c on that side. This c and this c will cancel. Always look to cancel. So y minus c is now equal to minus ax, which I've written here. So now our next move is to divide all terms by a, so we can simply say y minus c divided by a equals minus ax divided by a. The two a's will cancel and we're left with y minus c equals y minus c over a is equal to minus x. Now we don't want minus x, we want plus x. Just to fix that, we change the sign of the minus c to plus c and the sign of the plus y to minus y. So it's actually c minus y over a is our solution. Okay. Slightly more advanced one, make a the subject of the formula that is c equals a over 2 minus 4b. So the first thing to do is to clean the fraction by multiplying all terms by the lowest common multiple. Here is the problem. First we'll balance it by placing a 1 under this term and this term, just to balance up the equation. We'll note that the lowest common multiple is 2, so we'll multiply all terms by 2. Look for any cancellations, there's 1 there. 2 by c is 2c here. This becomes a, and this becomes 2 by 4b is minus 8b. And you should be able to see then that a then, because that's what we're making the subject of the formula, a is actually equal to 2c. Bring this over, becomes plus 8b. Let's look at evaluating and writing formula. So, for example, the charge C in euro for hiring a hall for an event is given by C is equal to 150 plus 2 times n, where n is the number of people at the event. Okay, so we're asked to find the charge when 250 people are present. So the formula to find the charge in euros, the charge C in euros is 150 plus 2 times the number of people who attend, that's 250. So C is 150 plus 2 times 250, 150 plus 500. The charge is 650 euros. We might also be asked to find the number of people who attended N when the charge for the hall was 790 euros. So for this case, we write our formula, C equals 150 plus 2n. We let C equals 790. 790 is equal to 150 plus 2n. So our 150 crosses over the bridge, becomes minus 150 is equal to 2n. Therefore, 790 minus 150 is 640 is equal to 2n. N must be equal to 320. Now, solving simultaneous equations. Solve 4x plus y equals 17 and x minus 3 over 4 plus y over 2 equals 5 over 2. So the first thing we need to do is to fix this second equation before we can solve it simultaneously by multiplying all terms by the lowest common multiple, that is 4. So we 4 over 1 times x minus 3 plus 4 over 1 by y over 2 plus 4 over 1 by 5 over 2. We'll look to cancel. They'll cancel, leaving us with just x minus 3 here. This will cancel with that. 2 goes in once, goes in there twice, leaves us with 2y. And 2 will cancel into itself once, and there twice, and 2 5s are 10. So we've x minus 3 plus 2y equals 10. So that's the same as x minus 3 plus 2y equals 10, just removing the brackets. So we've x plus 2y is equal to the original 10 plus 3, whose sign changes from minus positive as it comes over the bridge to here. So x plus 2y is equal to 13. That's our second equation. We've our first equation and we've our second equation. So now we can proceed to solve these like we normally do. We will now be solving 4x plus y equals 17 and x plus 2y is equal to 13. So what will we do? Well, we nail the y always, so we'll make this 2y first of all, and to do that we need to multiply all of the top line by 2. So 2 by 4x is 8x, 2 by y is 2y, 2 17s are 34. We still can't cancel our plus 2y and our plus 2y here, because although the coefficient is the same, they're both 2's, our signs are the same. So what we always tend to do is multiply the lower line by minus 1. Okay, so that becomes minus x minus 2y minus 13. Now we can look to cancel by saying 8x minus x is 7x. They'll cancel out, draw the line and cancel them out. And 34 minus 13 is 21. So that means that if 7x is equal to 21, divide both sides by 7, x is equal to 3. And we bring this 3 back up. Always we could put it back into our first equation. It doesn't matter which one you put it into, but we'll put it into our first one, our 4x plus y equals 17. So we'll plug 3 in there. So we have 4 by 3 plus y is 17. 4 3s are 12 plus y is 17. Y is 17 minus 12. Y is equal to 5. And if you have time, always in the exam, you can check by, we'll just go with the second one here. X plus 2y is 13, so our x is 3, plus 2 times our y, which is 5. 3 plus 2 5s, 10. 3 and 10 is 13. That means we're correct.